Alrighty, so it looks like we've got our audio sorted there. Looks like people are coming in, so we'll start off. Hey guys, welcome. So planning to do some of these streams in this little coronavirus period because I know at least I'm very bored, and kind of keen to keep working on some stuff and keep developing skills and whatnot. So I thought that we'd do these streams and hopefully we can get some people in and get some people talking in the chat and work through this kind of stuff. So today we're going to look at Vectorworks, and we're going to kind of start from a blank document and kind of like work from there. I know like a lot of people with Vectorworks, I like got a lot of messages from people about kind of their frustrations with Vectorworks, and I know for a lot of people that they like to use it as I guess both a drafting tool, but also as like a creative tool for kind of coming up with ideas, planning things, putting kind of thoughts on paper, I guess. And I think for a lot of people, there's that frustration of not knowing where to start or getting bogged down in a lot of the really boring stuff in Vectorworks, so they can't like have that kind of creative freedom and use it as that creative tool. So I guess we'll jump straight in and have a look. So we have a blank document here. All we've done is open Vectorworks. This is actually my blank template document, but I'll show you kind of how you can get there in a second. So we'll just quickly look over the interface. I'll just hide that little camera so you can see up here. So in the top left here is kind of all our basic drawing tools. So we've got a whole bunch of things. If you mouse over them, you'll get a little blurb that tells you what they are. So everything from kind of our camera controls, text, basic drawing tools of like polygons and shapes, snipping tools, basic dimensioning tools, all sorts of things up here. So this is kind of our generic toolbox. For the most part, this stays the same, whatever we're doing in Vectorworks. Below that, we have our tool sets, and these are kind of specific to the workspace that we're in. So we're currently in Vectorworks Designer, and we have the Spotlight plugin, which is kind of the main plugin that you're going to be using for any kind of entertainment drawing. So we start with kind of Vectorworks Fundamentals and Vectorworks Designer, and then Vectorworks Designer has Spotlight attached to it, which is the main drawing tool for entertainment. So because we're in the Spotlight workspace, and if anyone is following along and it's not working, or they don't have these tools, I should say, they can make sure they're in that workspace by going Tools, Workspaces, and make sure that we're set to Spotlight Australia. Because we're in Australia, we have the Australian Spotlight that's laid out by the Australian distributor. So now, because we're in that Spotlight workspace, what we have here is our Spotlight tools. So we've got kind of lighting instruments and cable, truss and rigging, and then kind of generic event things. And then kind of everything else in here is the more generic Vectorworks tools like lighting for renders, 3D tools, wall tools, furnishing tools, and then kind of our dimensioning tools and more detailed tools for drawing a lot smaller things than we're probably ever going to be drawing in entertainment. Below that, we have our attributes window, which is mainly going to be used for setting our like fill and line colors of kind of basic 2D shapes and the line thickness of the stroke of that tool. Below here, we have our snapping tools. Moving back up to the top, we have this bar here, and this bar is kind of contextual to whatever we're working, whichever tool we're working with. So when we have the, say, camera tool, we can see that the camera, sorry, I clicked the zoom tool there, the camera tool, we can see that our tools then become contextual to that camera tool. So currently we can change like where the center of our camera is and how it pans around objects. And if I was to grab the lighting instrument tool, we can see then that jumps to selecting what kind of instrument we want to place and in what mode. So this whole bar along here is contextual to whichever tool we have selected. Above that, we have our active class, which we can just drop down. To the right of that, we have our active layer. So we'll discuss them in a second. Here, we choose the plane that we're working off. So we have two planes in there. One is the active layer plane, and the other is the screen plane. So because we're just working in 2D at the moment, looking at the layer, we can just leave it on layer plane. To the right of that, we have some tools for kind of zooming our page and zooming to either the objects on the page or the size of the page itself, and we can see a zoom percentage as well. To the right of that, we have looking at our different like other working planes. So our working plane is a plane that we can move around if we're working on angles. and our active layer plane is always going to be in line with whichever layer we have active. So because we're just working on basic 2D layers, a plane that's kind of in line with that is fine. And then here we have our view that we currently have selected. So we're in top plan, and we can grab all our other kind of pre-created views here. To the left of this is our plan rotation. So currently we have our kind of what's based off our A4 sheet in our design layer. But we could kind of grab this and we could rotate, say 90 degrees, and that will rotate our page and our plan. We're going to go back to 0 so that we're kind of in line with our actual paper. Here we have a little checkbox for unified view, which makes sure that our 2D and our 3D objects are aligned on the different planes. And then here we have our different types of renders. So whether we're in a 2D plan or like a 3D orthogonal render or perspective renders. Here we have our rendering. So this is our perspective of our 3D render, and this is how it's rendered. So we have wireframe, which is going to be a basic wireframe render, hidden line renders, OpenGL right through to our full Renderworks engine, which is going to use Cinema 4D and properly simulate lighting and things. Here we have data visualization, which we might look at a little later, and then a bunch of other tools in regards to kind of grouping and rendering. Sweet. So all we've kind of done so far is got a blank document, and we're just in our blank document. Now this is my template document. Probably the best way to get to somewhere like here is to just start a new file and choose one of the Spotlight templates. So I've chosen here Spotlight Event, which is kind of the basic event template. Once you're in there, we want to kind of go to File and look at some of our document settings to set up our document. So probably the most important one straight off the bat is units. So here we want to look at, based on where we are in the world, what unit we're using. So here in Australia, that's millimeters. And we can set some of our accuracy and precision settings around the unit that we've chosen. So in this particular template, everything is kind of set to 1 mil, one whole unit, which is fine for entertainment works. If anyone is working within less than a millimeter accuracy, congratulations. Once we've done that, our document's kind of ready to go. We can look at some other preferences in the document preferences and the Spotlight preferences, but for the most part, everything's going to be pretty much ready to go. Probably the only Spotlight preference I'd ever recommend changing is, it's actually in Tools, Options, Vectorworks Preferences, which is another preferences window entirely. I'd recommend going to Display and turning off the Display Light Objects to either only in wireframe or never. Whenever we're drawing lots of lights, which we often are in an entertainment scenario, this option is an absolute pain because it treats them like render lights and gives us a huge interface around them that's horrible. So either only in wireframe or never. I'm going to set mine to never. So apart from that, our document's pretty much good to go for entertainment drawing. So we'll look over to the right of the window now, and we have a couple of different sections. We have this kind of box here is our object info palette. So this is contextual based on what items we have selected. Shape above that is more information about the shape and the records that are attached to that object, which we can talk about later. And then render is where we choose things like textures and colors that we're applying to objects and 2D shapes. So obviously we have no selection, so we're not seeing anything in this object info palette. Below that we have our navigation window, which is kind of how we get around our drawing. So we have classes, we have layers, which we can get through using this little tabbed window up here. Layers, we have our sheet layers, viewports, saved views, and references. So if we jump back over to the first box, classes, in classes and layers, we also get these options below to choose how we interact with our different layers. So if we're set to active only our active layer, which is the layer or the class that has a little check next to it, is what we can interact with. If we set to gray others, we can see our other layers, but they'll be grayed out. Gray/snap others will leave them every layer except the active one gray, but we can still snap other objects to them. Show others will show all our items, but we won't be able to interact with them at all. Show and snap others will once again show them all, but not grayed out in full detail, but we can still snap items to them. And then show, snap, and modify others allows us to work with every single item in our document, regardless of whether it's on the active class or the active layer. So if we move down to the layer section, we have our visibility columns down here. So the little I means that that item is that layer or class is visible. We click the one in the middle for the cross, which means it's off, it's turned off. And then the last one is gray, which leaves it visible but grays it out, which is great for highlighting certain elements that we're working on. So let's discuss kind of classes, layers, viewports. So all of these different windows here, we can kind of see all our classes and layers by double clicking on that particular tab. And when we click that, we'll get up like a contextual window for all the different classes and layers. And that works for all of these. So that was design layer. If I go to classes, it'll do the same thing. So there's a lot of different schools on thoughts on how we use classes, layers, viewports, etc. in Vectorworks. So we'll look at kind of our final output first, which is kind of where we're aiming to get to. So when someone hands you a piece of paper on site with a plot or a fixture sheet, etc., that is going to come from a sheet layer. So a sheet layer we want to think about as essentially our final export. So that's what we're going to export to a PDF or print. That's kind of where we want our final drawing to be. We've taken a view of our drawing, whether it's a 2D plan or a 3D render, and we've captured that view and placed it onto our sheet layer. And our sheet layer, when we're working on sheet layers, we're thinking really about paper, because our final export is going to be onto a piece of A4, A3 paper. Viewports are what we put on our sheet layers. So we can work in a totally 3D or 2D space in Vectorworks, but when we need to, it comes time to decide what our export is actually going to be, we need to kind of capture a certain view. And so viewports are that, and we place viewports onto sheet layers. And viewports have a lot of different options. We can select what classes and layers are visible, choose rendering modes, etc. But eventually we're going to get a collection of viewports. We're going to put them onto sheet layers. Design layers and classes. Now this is where it can definitely be up to your own interpretation. But essentially you need to think about both of them as ways of separating things. So layers are a lot like layers in Photoshops or Premiere Pro, etc., where we have different layers and they comprise of different objects, and we can kind of stack them one on top of each other. So this number here is our stacking order, and that is in a 2D space. You can kind of bypass this, but by default, this is what layers are going to be on top of each other. So at the moment, rigging is our top layer, and venue is our bottom layer. And we can grab this little page that appears when we hover over the number and drag items to rearrange their stacking order. So layers are just like layers in Photoshop in that sense. Classes are, much like in programming, classes are definitions of objects. So classes can have lots of different like attributes applied to them. They can have definitions applied to them. And they can, say, take a group of objects and color them all a specific color, or define their dimensions as a specific value. Now, the way that often we're going to use them in entertainment is for further separation of our items. So I like to think of design layers as kind of what I want to have on my final export, maybe your departments or your different production elements. So say rigging, lighting, video, audio, they're all different production elements, and they're kind of our big picture items. So this can act as our on-off switch for all our rigging, all our lighting, all our video, all our audio. So that's kind of our first degree of separation of all the different elements in our drawing. We've got some good chat action going on here. Laser sloth. An ogre has layers. Indeed it does. So classes, on the other hand, we can use for further separation. So if we want to produce exports that have different elements turned on or turned off in the final export, we need to have a way of controlling that. So it's really important that we keep our class and our design layers somewhat neat, so that we have easy ways to control different things. So I've kind of got two levels of separation here, which is I have my audio here, which is kind of my big on-off switch for all my audio elements. And then in my classes, I have further separation of those items. So we've grouped them here to try and keep things a bit more neat, a bit more organized. You don't have to do that, but we have kind of our delay PA and our main PA. If we went down to, say, front of house, we have like our front of house consoles, the riser that front of house sits on, tables, etc. And then we kind of have 2 levels of separation. Now, we could go even further into that and say separate things by positions or where they are in the drawing or in the venue, what their purpose is, but kind of this is the most basic form. But we could definitely add further layers to this by, say, separating things further out here in design layers by positions, which is sometimes handy if we want to display, say, only one truss or one audio position in a viewport. So to create design layers and classes is really simple. We can right-click in this class field and we can choose New. And then we get a box here that's asking us what we want to create. So we want to create a new design layer and we can name this design layer. So let's say for this instance, call this one Stream. And then by hitting enter, we create a new layer. Same goes for classes, but in classes we have one more option because we can group items. So we can go new again and create a new class. But what we can do here is rather than just saying stream, we can add a dash and say stream 1. And now when we create this class, what we end up with is we end up with a group that now has this 1 inside it. So the dashes are layers of separation in the groups, in the folders, if you want to think of it like that. Cool. So we're kind of set up in our document now. Our document's ready to work off, and we have a bunch of classes and layers created. Like I said, this is kind of my template file. So I've gone through and created a lot of what we're going to need. So now our next step is to kind of start drawing. So this is a step that a lot of people asked kind of what the best way to go about it is. Now, unless we're kind of drawing a completely freestanding thing, we're going to usually be within a venue or maybe on a site for a festival, and we're going to probably start with like a PDF that was been supplied by the venue. Sometimes if we're lucky, a DWG or a Vectorworks file. But in a lot of cases, we're just going to usually have a pretty basic PDF. Now, so we can draw within our venue and, you know, adapt our show to our venue, we want to be able to get that PDF in here and work off it, even if it's just a basic 2D PDF, so we can start to lay out our items within the venue. So I've gone ahead and downloaded a PDF from a very infamous Sydney venue, and we're going to import that. So the way to do that is use our contextual menu up here on a Mac, and on a Windows it would be the top bar of Vectorworks. We're going to go import PDF. We're going to grab our very infamous venues PDF here and import it. And we're going to grab this page selection that says what do we want to import. Now our PDF only has one page, but so we only have one option, but we could choose different pages to import. And we're going to click import. This is quite a big PDF. It's very detailed, so it'll take a second here. But once we're in, we can see we have our PDF imported, and it's a rigging plot for the top level of halls at the ICC in Sydney. So once we have our PDF in, we can see that this has a lot of extraneous detail on it that we don't particularly need to start working. So we're going to double click on this, and generally double clicking things in Vectorworks gives us abilities to either dig into a deeper layer of them or control something about them. So when we double click a PDF, we're going to get the option to create the PDF crop. So what we've done now is we're going to crop this PDF in. And generally whenever you're in Vectorworks and you see this yellow border appear around your window, it means that you're editing a grouped item or an item that's been defined. So that might be a symbol, an object, a PDF. And we're not actually working on the design layer right now. We're just working on this one object that we've selected. So when we have viewports or PDFs or images, we can crop them. So what we can do is we can grab any of our basic shape tools up here, and we can drag out a box. And then what this is going to define is it's going to define what part of the PDF is actually used by us. So we've now drawn that box. We'll select that box, and it's going to crop that PDF. So now you can see that everything is grayed out around the box, and only the white box is visible. So we can drag that in a bit further to get a bit more accuracy here. And then we can exit our PDF page crop. Great, so now we have our PDF imported into our document ready to work off. So this is a pretty standard floor plan that you might get from a venue. Sometimes you'll be lucky and you'll get a DWG or a Vectorworks. We might look at a Vectorworks for a venue in a second, but this is kind of the most basic of all. And this is great because you can use anything. You can use a PDF grab of Google Earth, Google Images. You can screenshot something that's provided to you by a venue, anything really. So the only problem with what we've brought in now is that it's not to scale. So obviously when we're working in Vectorworks, we want things to be accurate. And this is only the size that the original A4 page that we exported out of Adobe Acrobat was, which is why you can see that our A4 page and our design layer is basically the same size as it. So what we need to do is we need to scale this item. So what we need to do is we need to have a defined value in this PDF. So that might be going to site and measuring something, or looking at another drawing to try and determine any measurement in this this venue. That might even be as simple as knowing that the standard door width of a door frame is a certain dimension. So I was looking at some other drawings of this space, and I know that from this wall to this wall is 100.4 meters. So that's our reference dimension for this drawing. So what we can do is we can grab this and we can go to Modify, Scale Objects. And what we can now choose is Symmetric by Distance. So Symmetric by Distance is basically saying we're going to take one measurement in our current drawing and scale it to a new measurement, and it's going to symmetrically apply whatever the scale that we need to apply is to the whole drawing. So what we can do is we can go Symmetric by Distance and choose this little box here, which is going to give us some pointer tools to use in the drawing. So we click this. And now we were saying that from this top wall to this bottom wall is 100.4 meters. So we'll go over here, we'll zoom in, we'll wait for the PDF to buffer itself out here, and we'll grab this wall. We'll then zoom out and move our camera up. We'll talk about the camera tools in a second. And now go to this wall. We can see our line here that we've created. And when we're working with any pointer tool in Vectorworks, we get this little box next to the cursor. So that tells us the length and the angle that that line is that we've just drawn. And you'll get different options depending on what you're drawing. So what we can do is we can hold Shift, much like you would in, say, Photoshop or Premiere Pro, to try and to keep things symmetrical and, to scale, square. So say when you're scaling something in even Microsoft Word, you hold Shift and that keeps the scale the same. Well, it does the same thing in Vectorworks. It keeps things either to scale or square. So when we hold Shift, it becomes square, and we can see now that our angle is 90 degrees and that the length on this PDF is 7,000 millimeters. So we'll click on that other wall, and it said, great, your distance that you just measured on your page is 7,000 mil, and it's saying how big do you want that distance to actually be. So we're going to type 100.4, and Vectorworks will recognize letters that represent different units of measurement. So we'll go 100.4 meters and hit enter. So what our PDF's going to do now is blow out, and now we've scaled that to the correct scaling for the venue. To check that, we can quickly look here. So when I'm moving the camera around, all I'm doing is using my mouse. I can hold spacebar to get this pan tool, and I can zoom using my mouse wheel. Okay, so we'll zoom in here. To check our scale, I also saw in that drawing that between these two openable walls was 44 meters. So we can grab from our basic tool set up here, start exploring these tools, we can grab our tape measure. So if we've done this correctly, between these two walls, we should have 44 meters. Ooh, just click there. Holding Shift again to keep my tape measure square. And you can see that we've got 44.9 meters. So we've scaled that pretty well. We might be 20 mil out, but once again, in an entertainment context, that's not a whole lot. Great. So now we've kind of got our blank canvas to draw off. So this particular drawing has rigging points in it, which are these little pink spires here, and these blue ones along the side here. So usually they're obviously what's going to define, in most contexts, in an indoor venue like this, our ability to rig things and what our production layout is going to look like. So we might start having a quick look at some of the spotlight tools in that case. So we can come over here to our spotlight toolset, and we can see that once again our first little box here of tools is lighting and cable. Our next is rigging, so truss, hoist origins, some more complicated rigging tools. And then this is our kind of generic event items, so seating, soft goods like drapes and curtains, ropes and stanchions, stage deck, stage steps, which are all our tools we can use for, say, risers and things. Televisions, projector screens, blended projector screens, LED screens, and then speakers and speaker arrays and video cameras. So all these tools, like we were saying earlier, when chosen, will produce a little contextual menu up here of what we're actually doing. So we might start by inserting a piece of truss. So it's really good when you start the drawing to go through and kind of insert one of the objects that you're going to use for every type of object. So insert one piece of truss, one lighting instrument, one speaker. And the reason we do that is because it's going to start creating some automatically created classes that are going to populate down here, such as lighting. Here you can see it's created all the classes that it needs to represent a lighting object. So you can you don't need to do that, but if you do that at the start, it means that your class structure is going to start to become apparent down here. And as well as the classes that you've created, any that Vectorworks needs to create or wants to create based on how the symbols that you're bringing in are drawn, you can do at the start, and you'll kind of start to see what this looks like. If you do it in the middle of the drawing, it can start to get pretty messy. So that doesn't need to be every single different light you're going to use. It doesn't need to be every single different piece of truss you're going to use. It just needs to be one so that it can start to create its, say, rigging truss classes, rigging hoist classes, etc. So one thing we haven't looked at yet is the resource manager. So I'm going to hit Command R on a Mac. I believe it's Control R on a Windows to bring up the resource manager. So the resource manager is where all the different resources that are used in our different files appear, and all the libraries that Vectorworks provide to us with objects we can use are shown. So you can see I have my 3 open files here. The one we're in is stream number 1 Hall. And then below that we have our different libraries. So the Service Select libraries are libraries provided to people that have subscribed to Vectorworks Service Select service. Vectorworks libraries are the libraries included with Vectorworks. And then we have user libraries, which are libraries you can create yourself. So we'll look in the Vectorworks libraries, and we can see a whole different bunch of folders of different objects. So probably the ones most interesting to us begin with ENT, entertainment, and we have, say, audio. We can open this folder up, and then we can see a bunch of different categories of items. They're usually separated by manufacturer or type. So we have, say, speaker bumpers by JBL, or speakers by EAW. We can close this and jump into a different folder, say entertainment lighting instruments, and now we have all our different lighting manufacturers and their different instruments. So if I was to, say, go into the Ayrton folder, we'll jump into American DJ because I can see it. There we go. And now we have all their different types of products that they manufacture. We can click on the folder, and then we'll get all the symbols over here. So if we were wanting to place, say, a piece of truss, we can jump into our truss folder and look for which piece of truss we want to place. So we've got all our truss manufacturers here. We're going to jump into Eurotruss or, say, Cosmic Global, because Global Truss is pretty common in Australia. We have all our different series of truss, and we can choose a category like F33, which is tri-truss, and straight sections, and then over here we get all our straight F33 sections at different lengths. So you can see that they're pretty handy. I'll open this up a bit wider. You can see their record items here. So records are applied to these things, which are symbols and contain information about the symbol. So Vectorworks has a whole bunch of different records that are applied to symbols, and one such one is the truss record. So truss needs to have a model name, a manufacturer, a length, width, height, and all this other information. So because Vectorworks have gone through and created all these libraries and all these symbols, they've filled out that record for us. So we'll grab, say, a section of Cosmic Global, and this is a 1.5 meter section of FD33, and it's apex down. So we could grab this symbol right now, any of these symbols, and we could just grab it and drag it into the drawing. You can see Vectorworks is going to download this symbol because I haven't downloaded this particular symbol, and it's going to bring it into the drawing. It's going to say, okay, you're importing this into the drawing, so where do you want to import the resources that it needs? Usually it's pretty fine for most cases to just say preserve folder hierarchy, unless you're getting super organized in how you organize all your different records, or your different resources, I should say. What Vectorworks is intending to do is usually fine. So preserve folder hierarchy will go with its folder structure that already exists within the document, and any folders that aren't made it will make for you. So we're going to say OK. And now it's going to say that this truss record already exists in the current document because we've already put a piece of truss in here in the past. So what do you want to do about the clashing records? So we don't want to replace all the existing truss records in the drawing or rename them or anything. We just want to merge them. So that'll kind of add the additional truss records that we're bringing in. So now we've dragged this in. Now, the only thing about bringing in any symbol that way is it's going to bring it in basically as just a 2D, 3D symbol. So you can see up here in the object info palette, now we actually have something selected that it's just a 2D, 3D symbol. We can put it on a class, or put it on a layer, I should say, and assign it a class, and give it some X, Y, and Z values. But that's it. That's all we can do with this piece of truss. So Spotlight has lots of truss tools and truss capability. So we kind of want to take advantage of them. So we'll delete this piece of truss, this symbol that we've dragged in. And instead we're going to go and have a look through the Spotlight menu at what tools it has available for us. So we have right at the top, we have drawing a lighting pipe ladder, inserting a truss or connection, or a straight or curved truss tool. So straight and curved truss, these two tools, are going to have Vectorworks generate the truss. So it's actually going to draw the truss based on parameters that we give it. So if we were to click that tool and just draw a line, it's going to ask for all the information about the truss. So what type of truss it is, what its dimensions are, the spacing of all the webbing and things, and then it's going to actually generate that truss. So unless you spend a lot of time looking at data sheets and drawings and going through and filling out all these boxes, that's obviously a huge amount of time. So what we can do is instead, we can use the insert truss tool. And what this is going to do is just use the existing libraries and symbols inside Vectorworks to place a piece of truss that have already been defined by Vectorworks and by the truss manufacturers. So we can go select in this contextual menu that's now appeared, we have some options. So magnet will snap bits of truss to each other, which is the auto connect feature to join them together, which is a feature that's come across from Vectorworks Braceworks module. We can use single insertion to only insert one piece of truss, or multiple insertion to place as many trusses as we need to match the length of the line that we've drawn. So if we draw an 8 meter line and we have a 1 meter piece of truss selected, that will insert 8. Here we can choose whether the truss is placed horizontally, vertically, or on an angle. And when we choose the angle, we can put in any angle in this hanging angle box here. So what I'm going to do is I'm going to say insert a truss symbol. So we're going to click this little contextual box and it's going to bring up the resource manager for us. So what we'll do is we'll go back into this Cosmic Global folder and grab the F33 straight tri-truss. And we'll grab let's go 2 meter section of truss, which will be F33 200. So this is now a 2 meter section of truss. So what we can do is we can go select. We're going to have to once again merge in the new truss record. And now we have that selected up here, and it's saying that we have a piece of F33 200, which is the model number, which is a 2000 millimeter piece of truss or 2 meter piece of truss. So we're going to insert our truss horizontally, and we're going to use multiple insertion or distributed insertion. So looking at the floor plan that's been provided to us by the venue, we can see all our rigging points. So we're going to draw this between a couple of points. So we draw a line by clicking and holding. You can see this red line start to appear. Now obviously this line could go in any direction, but we want it to go between these 2 points here. So by holding shift, once again, we get this little pop-up that says vertical. And we now know that we're locked to 90 degrees, and this is a straight line based on where the first point was placed. And when we click, we see that we've now created a truss comprising of 5 sections of 2 meter F33 tri-truss. Now, when we look at the object info palette, as opposed to before, where we just had 2D, 3D symbol, it now knows that these are truss objects, and it gives us a whole ton of options relating to this truss. So we can apply roll to the truss, which would be like lateral roll, like a truss that's poorly balanced rolling over. Hanging angle, which would be hanging angle as if we were angling the truss using motors or on that longitudinal plane. And then rotation, which is rotation around the z-axis or the top axis, so that when we're in this top land view, if we were to apply a rotation at 80, we can see they've all rotated to 80 degrees. We also have position up here, so x, y, and z value within the drawing. Currently, this is set to an x value, a y value. A y value is blanked out because obviously every piece of truss has a different y value, y being this direction, but they all have the same x value because they're in a straight line. And z is our height, so when we start working in 3D, that'll be important. So let's say that this truss is at 7 meters. So 7, place our m for meters, enter. So it's now jumped to 7,000 mil or 7 meters. So now, really cool thing about Vectorworks is that we've been working in 2D this whole time, but all of this information is in a 3D space. So if we were to grab our camera flyover tool, which is up in our basic tool set next to our panning tool, and grab the little orbit here, the flyover tool, we can now orbit around the drawing, and we'll see that we have our piece of truss here at the 7 meters that we placed it at, and we have our flat 2D floor plan that we imported into the venue. Now we can choose some views that we could jump around in 3D. So instead of custom view, we could choose, say, front. We'll get a view from the front. Left, we get a view from the left. And then we can jump back to top, which will be a top drawn in wireframe in this render mode, or top plan, which is our basic 2D drawing. Great, so we've drawn our first piece of truss and positioned it within the drawing. So that's why we want to try and find the tools that Vectorworks is providing for us to work with entertainment objects. We can drag them in from the resource browser, but for the most part, they're just going to come in as 2D, 3D symbols, and they don't take advantage of the parameters that Vectorworks have applied to different types of objects. So for example, with truss, that was all our angles here, our lengths, our names. We can ID different bits of truss. We can choose to draw it in 3D only, and we have all these buttons down here that let us do other things like select objects of the same symbol, which would be the same type of truss, select objects with the same cross section, select system objects, which is any objects that are connected to the truss. So if I click that, you'll see that we now get all these bits of truss that are joined together. Change trim height, so change the height of the truss, and change the configuration, which would let us use different sticks of truss instead of the 2 meters that we used. So we've placed our truss. What other items do we have available to us in this Spotlight toolset? So we have lights, speakers, video walls, a whole bunch. All of these are going to be used much the same as we did with the truss. So if we grab this lights toolbox here and grab, say, a lighting instrument, once again, we're looking to this contextual menu, and we're going to entertainment lighting instruments, which is automatically opened up for us, choosing a manufacturer. So we'll choose, say, Arton this time. Looking for the light that we want to place. We could easily do that as well by just searching. So let's search for a Mistral, say, an Ant Mistral. We search in the top bar up here and we get any items with Mistral in them. I'll grab a Mistral S. Once again, exact same as the truss, choose select. It's going to download that symbol if we don't already have it downloaded. And now we're ready to use it. Much like the truss tool, we now have this ready to place. And we could say go to the piece of truss we just placed. Click. Click. And now we've just placed a Mistral in the drawing. We have a couple of options when we place items like lights or speakers or LED screens. There's a couple of different stages of clicking. So we have it here in our cursor, and the first click is going to place it at that spot. And now we get a rotation option. So now, based on where our cursor is, we're going to rotate the object. And you can see once again, our object has a little item next to the cursor, which is the length of the rotation around the center point, and then the angle of the rotation. Now, whenever we have this little context box, we can actually interact with it by hitting tab. So now when we hit tab, we see that our cursor jumps to this box. Length isn't that applicable when we're rotating something like this, but angle certainly is. And we could type in an angle of 45 degrees and hit enter. We see this red line come up to show us the rotation that we're going to apply to this object, and hit enter. And now we've placed a light at 45 degrees. Now, just like the truss, because we use the lighting instrument tool, when we click on the light, we can come over into our object info palette and see all the different fields and parameters that Vectorworks knows about lighting instruments. So we see our rotation around all three axes, our position on all three axes, what the device type is, the name of it, the wattage, which is very useful when we're doing power loads and looking at how much power we're going to be drawing with our rig. And then these blank fields are all for you to fill out. So our unit number would be our unit ID or fixture number. We've got positions, purposes, colors if it's a generic fixture with gel in it, channel numbers, user address, universes. These are all the boxes that we can fill out to begin to populate our, say, lighting plot. Scroll through, more information about the light, which is all things that have come in with the symbol that we placed, and more options that we can use to interact with the light. Great. Let's try one more tool. Let's try, say, the speaker tool. Speaker. So once again, we can click speaker to select that tool. And this time we don't get the contextual box up here to choose the speaker, because this tool's built a little differently. It's built like the straight and curved truss tool. So we can just go anywhere in the drawing, click to place. Again, we're going to get that rotation as our second little click here, so we'll place it on that angle. Now this box pops up to ask us about this speaker. So we can go in and generate a speaker based on different lengths, dispersion angles, listening heights, etc. Or we can use some of the information that Vectorworks already knows about speakers in symbols. So we can click this little box, or we'll actually just place the speaker first, sorry. We can go in, we can say type, import, and we can grab any of our manufacturers that we've imported into this tool. So say Nexo, and then grab a speaker by Nexo, hit OK, and now we've placed that speaker. So by digging through these toolboxes and placing different items, you can very quickly start to see how the tool works. And just by playing with it, by attempting to place the item and interacting with the context box that pops up, you can definitely try and work out how the tool works. Certainly how I learned to use the majority of stuff in Vectorworks. Try one more, we'll try Stage Deck. So once again, this is a tool that actually generates the item rather than just placing a symbol. We can click, set an angle, and we get this box pop up again. We get a whole bunch of different parameters in regards to our stage deck. So the depth of the deck, the width of the deck, so these are pretty standard dimensions in Australia, 2400mm by 1200mm. The height, so again we'll set this to 300mm, which is a pretty standard riser height. The thickness of the top of the deck, so 25mm for some 25mm ply. The trim height, which is the trim on the side of the deck. Leg options, so we'll choose round legs. I've personally never seen octagonal legs. Whether the deck has wheels on it, so let's say this is a rolling riser and it does, and then whether it has any railing around any different sides of it. Once we click OK, based on the parameters that we gave Vectorworks, it's going to generate us a stage deck. And if we now jump into 3D and pan around that object, we'll see that we have a stage deck generated with the parameters that we chose. Oh, where'd it go? Here it is. So we now have a 300mm stage deck high with wheels on it, placed in the drawing. Sweet. So all these tools are ready to go in the toolbox here, and by playing with them you can definitely learn how they work and what they do. So we might try and draw something of a drawing here, and then start to add in the extra details that often come with a drawing like this. So we've got our piece of truss hung, and we said that its trim height is, say, 7 meters. We've drawn it into the drawing, and we're ready to start putting items on it. What we might quickly look at is importing hoists, because they're obviously a very important part of any kind of job involving rigging. So we'll jump into our rigging toolbox here, and we can choose hoist. Come across and look at the piece of truss, and now we're going to start to see some more of the functionality that is relatively new in Vectorworks. It's from Braceworks, and we'll be able to put this hoist on this truss, and you can see that red line is indicating what rigging object it's going to attach to, and then the red diamond is where on that rigging object it's going to attach. So we'll go over our rigging point here. Obviously that's pretty rubbish place being right over the end of the truss, but we'll do that for now. We'll see we're lining it up with the red rigging point on the base floor plan, and then we click place, and in comes our hoist. So we've got a bunch of information here that we can kind of customize what's displaying. We're looking at the X and Y value of the hoist from the origin of the drawing there. And we've got some other information down here. You can see that based on the fact that we applied it to the rigging object, it's actually taken on the height of the truss that we placed it on, and it's placed itself about 140 mil above the truss, which is allowing some room for rigging to take place with span sets or truss pickups, etc. And now we can jump up into our object info palette, and we can see much like all the other objects we placed, we have some options. So let's say that instead of being a half-ton hoist, this is a 1-ton hoist. You can now see that the symbol changes to the 1-ton hoist symbol that Vectorworks has defined, which is going to match up with rigging standards. And we can change some other parameters of the hoist. So we've now got an allowable weight of 1,000 kilos because we changed to a 1-ton hoist. See that we've got this hoist specified as a CM lodestar. It doesn't particularly matter unless we're doing reporting out of Vectorworks. We can choose whether the hoist is in the hoist down or up position. Some people say inverted, but definitely hoist up or down is a lot clearer. And a heap of other options. One of the most important ones is function. So by choosing function, we see some predefined hoist functions that Vectorworks has, and these are probably all you're going to need to do different types of shows with all departments drawn. So if we choose lights, it's now going to change to this red symbol. So by defining our hoist by function, we can separate them by color, and it definitely makes plans a lot clearer to look at. We'll scroll through. We can see that our high hook height is at 13,000 mil, which would be the height of our rigging point in the roof of the venue. Our low hook height is at 7.4 meters, which is where the low hook of the hoist is sitting, and our load trim is at 7.1, which is obviously the gap that is created automatically for rigging like span sets, and that's defined by the low hook to load trim value there. You can see that as a result of that, our chain length is displayed automatically for us, which is useful for choosing the type of hoist we're going to use. And then here we have some values to do with the weights that we're placing on the hoist, the speed of the hoist. Obviously, different speed hoist is going to have different dynamic forces because it's stopping and starting. This is all options to do with that. Keep scrolling down. Another really important option, if we're going to try and use this drawing to, say, mark up the floor of our venue, is where these X and Y values it's getting are coming from. So at the moment, it's coming from the drawing origin. Drawing origin is the center of the page, usually. So if I just quickly drag this out of the way so we can see our page on the design layer, which is right down there, that little crosshair there is the drawing origin, which is based on the center of the page that the design layer we're working on is based around. We can change that. We can change our origin by going Tools, Origin, and then saying User Origin to set our user origin based on a mouse click or a value, an XY value that's relative to that drawing in that origin in the center of the page. But moving our origin can be super destructive. So we need to think about whether it's a worthwhile step. Sometimes if you do it right at the start of the drawing, it can be great to place it, say, downstage center or in the center of your room, so that all your X and Y values are based off that downstage center point or the center of the room. It can make things a lot less confusing, because if we put something at -6 meters and 6 meters, they're symmetrical on either side of the room. We've kind of already started the drawing, so I'm not going to do that. I'm just going to continue with using my my internal drawing origin, which is in the center of the page, since we've already started placing some items. Definitely a great step that you can take at the start of a drawing, though. We don't really have a stage here as such, so we'll just roll with what has been created for us. So, if we do have that situation and we want to have our hoist reference to something other than that drawing origin, which is these X and Y values here, we can use another tool just below hoist over here, which is hoist origin. So, if we grab hoist origin and place it somewhere in the drawing, obviously somewhere that's going to be easy to find in real life. So let's say that we place our hoist origin. Obviously, if you weren't using the full venue, you'd find somewhere more local, but let's say that our hoist origin is, for the sake of it, in the node of this roof here, in the center of this door. I'm sure you could find somewhere much easier to find, but we'll place one here. So now we're going to get our origin, and we're going to place it. And now our origin here is spot number 1. And now, if we go back to that hoist that we've placed, we can select it, and back in the object info palette, say that rather than basing the X and Y value of this hoist off the drawing origin, base it off spot number 1. So you can use that to find, to give XY values to all your hoists based on an origin or a datum, as people would call it, in the room. And then you can use these values with some tape measures to mark out your floor and work out your rigging plan. Cool. What other stuff do we have in the hoist tool? Below that, we now have these displays section here, and the relative dimensions. So these allow us to toggle what kind of information that we're showing around the hoist tool. So we can turn off the label, we can turn off the data, which is what's all that stuff below it. And then we can also turn off these relative XYs. So we can turn off the labels of this data down here and just display the data. We can turn off the relative XY, which will get rid of those values up there. And then we can obviously turn it back on if we want it there. Now this stuff down here is called the hoist data display, and we can customize what stuff is shown there as well. So we can turn the whole thing on and off by saying display hoist data, or we can choose this set hoist data display box. Now here we get a context box pop up where we have all our different parameters, which are all the things that we're setting in the fields up here. And we can choose whether we want to display those on the drawing or not. So hoist type is certainly useful to know what type of hoist it is. We could add another thing like manufacturer, and then maybe we'll add the high hook height as well. We can change other things like the size of the font, the style of the font that's being used for this section. And we can choose whether to assign these new options to just this one hoist we have selected or every hoist in the drawing, and whether these options are default for any new ones we create. So now, if we hit OK, we've now created a display here, a data display, with all that information that we chose in the window that popped up. Great. So we've now got a truss. We have a motor that's attached to it. Motors are also drawn in 3D. We'll look for an option in here, which is one other option we didn't discuss. Where is it? It is the option for drawing in 3D. Here we go. Realistic chain. So this is going to decide whether in 3D we draw a real looking chain with links or just a line. It does have a bit of a hit on performance, so you can choose whether or not that's turned on. We'll turn it on for the sake of a good looking drawing. And now if we orbit around this point, we can see our truss is created. It has a motor attached to that end, and a chain that ends at our 13-meter high hook height that we set. Awesome. So I suppose we've got our truss. We should add another hoist. Our hoist is gonna, on this side, is gonna have the same parameters as this one. It's gonna be at the same height, the same load trim. So we can just duplicate this hoist. So there is a shortcut, which is Command D on a Mac for duplication. We're now gonna create a second copy of that hoist. We can drag off that point, and then we can drag it down to this end of the truss, and we'll get our auto connect options again. With that red line, we'll drag it over the point that's in our PDF drawing and place it. Great, and there we have another hoist at the same heights of both our trim and our high hook height, the same parameters, and it's measuring off that same datum that we created. Sweet. So what might we want to put on our truss? Let's try some lights. So we'll grab the lighting instrument tool, select the light, let's stick with the Mistral, and we will place it on this truss. Now, we can place the light directly on the truss, which is, for the most part, how I draw most things. There is one more option that Vectorworks offers us, which is called a hanging position. Now, this is a definite point of contention when I talk with a lot of my friends that also draw in Vectorworks. Now, a hanging position is used to kind of define this one piece of truss as one hanging position, rather than lots of individual pieces of truss. It's really, really good in theatres where you have, say, pipe battens and things, and you can define that one long piece of pipe as a hanging position and then hang all your units off it, and then generate, say, reports for just that hanging position. We'll try and create a hanging position here just to see how the tool works. It definitely has advantages and disadvantages. For a quick and dirty drawing, there's no problem with just attaching the light directly to the truss. But if you think that you're going to want to create reports out of Vectorworks, position summaries of different positions, so that, say, if you're doing a big venue like this, you can have little summaries on the drawing of what lights need to go to what locations, and that can be definitely useful packing trucks or during bump in. So what we'll do is we'll grab all our rigging objects that we want to use for that hanging position. So, like in a lot of other programs, if we hold Shift and then click on multiple items, we can select them all at the same time. And now what we can do is scroll down either in our truss tool and choose Convert to Hanging Position, or we can go Spotlight, Rigging, Object Conversion, Convert to Hanging Position. So now it's going to say, do you want to make a lighting / other object hanging position from every single selected object, so that we have 1, 2, 3, 4, 5 different little hanging positions? Or do you want to create a single hanging position from every single item that you have selected? So let's choose that, because this is going to be one truss in our rig. We don't want separate individual breakdown for every single piece of truss. So we'll go create a single hanging position from all selected objects. So I'm going to say, what do you want to call this? Well, let's call it a designation like room truss. And now it's going to say, do you want to create a symbol? So symbols are all those things in the resource browser, if you remember, from the geometry that we're using for this hanging position, or do you just want to use the basic geometry? So creating a symbol is great, because what it'll do, we'll group all these trusses together, remember the information about them, and throw it in the resource browser. So if you need to create 10 of these trusses, 10 of these different hanging positions with different names and things using the same exact truss, like you might in a room like this down the length of the room, you can just drag it straight out of the resource browser and use all the stuff you already set up. But if it's just a one-off truss, well, it's kind of just as easy to just use the same, the individual geometry of all these different trusses. So we'll choose that option. So now you can see that we have a hanging position that's been generated. So when we select this truss, we select the whole thing, all the bits joined together. We get a label here, and in our over in our object info palette, rather than just seeing 5 bits of truss, we see a hanging position, which has parameters associated with it, just like every other object. So we could rotate this hanging position, say 120 degrees, and all the truss rotates together. We could turn off this little label that says room truss, or turn it on. We can insert a position summary, which we'll have a look at once we have some lights, and a couple other different options. But we have a basic hanging position now. We can then grab our lighting instrument tool. We've still got that air and mistral from before selected, and we can drop that on the hanging position. So let's say drop a light here. Great, and just like that, we've placed a light on the truss. So we'll start to experiment with some of the other tools that we have here. We'll delete this light that we just created and create one a different way. So looking through our basic tool set, we have in this kind of section here some tools that can help us interact with our selection. We have rotate tools, mirror tools, which will mirror things symmetrically along a plane. This is a super duper useful tool in entertainment. We've got some split tools for splitting items, trim tools. We also have this distribute tool, or move by points, distribute by points. So we might try the mirror tool and the distribute by points tool, because they're two super useful tools, especially in an entertainment context. We also have a line and distribute down here in the lighting tools, which is kind of a specific tool Vectorworks built for distributing lighting instruments. But we'll stick with the basic tool set for now. So we'll place a light on the truss here, and we'll place another one just next to it here. So there's two lights on our section of truss. Now, a great time saver when you're building a truss. Here's a question. How do I keep the mirror tool from messing up fixture rotations? I assume that you're mirroring one side of the truss to the other. So the mirror tool, which we are discussing now, is super useful whenever you're building a truss that's symmetrical by the middle point, so that you can draw the fixtures on one side, and then rather than having to go through and rebuild the entire side of the truss again, you can just use the mirror tool to mirror it, and everything will have the perfect spacing. So we can, to use the mirror tool, we need to first select our item. So we'll select these two units, and we'll move this label because it's kind of going to be right in the way. It's worth mentioning now that with a lot of the functionality that's come across from Braceworks into Vectorworks, they've included a lot of the stuff that previously you had to spend a ludicrous amount of money on Braceworks for. These lights, because we place them on a hanging position, they now have this little drop next to them when we select the hanging position, and this is indicating that they're attached to the hanging position. We can actually grab this little handle here and offset them from the hanging position if we want to make our drawing easy to read, and they're still counted as included as part of this hanging position. That's awesome, because what we can now see is if we look at our total hung weight over in the object info palette over here, Vectorworks is starting to do some smart things regarding rigging for us, including calculating weights. And then if you were to bring this drawing into a copy of Vectorworks with Braceworks installed, I don't have it, but certainly one of the people I work for does, then it's as simple as them clicking a button to run calculations and get Braceworks calculations. So Vectorworks has done this as a result of us making a hanging position, because it knows that we're going to start wanting to associate loads with this, be it speakers, lights, LED screens, etc. So back to the mirror tool. We've got our two lights that are attached to our hanging position, and we'll click them. And now we'll find the middle of the truss. Since we're using an odd number of sticks of truss, it's a little more difficult than just finding a join, but we can find the midpoint of the truss right here. We get all these little red boxes that pop up, which are like targets for our cursor to snap to. They make it heaps easier for us to find different points. You usually get one for midpoints along different lines, like the chords of truss, etc. So we've selected our two units and found the middle of our truss, which is going to be our axis of symmetry. We can grab the mirror tool, go to that point, and then all we want to do is draw a straight line. It needs to be a straight line, or we're going to offset on a different axis of symmetry. We'll grab this midpoint, draw a line out, and then you can see it's on an angle here at like 171 degrees. And you can see these little blue boxes are drawn, which are where our duplicates are going to end up. So you can see as we angle, we're mirroring on a different axis. So we can hold shift again to get that thing to square things up for us. Double click. And just like that, we've created 2 duplicates symmetrical on our truss. So the question here was, how do I stop it from messing up fixture rotations? We'll try a rotated fixture. I believe it's always worked for me, but we will try it. So if we keep these 2 fixtures and say rotate them 45 degrees around the z-axis, they're pointing in. Obviously we don't really do that with moving lights, but this might be a conventional. And we'll delete the 2 over this side. And then use our mirror tool. I did this the other night and I do remember it working, but maybe I'm delusional. Oh, I lost the selection. When you're using the mirror tool, you can hold the command key to select, so you don't have to keep changing over to the pointer tool. Not hitting the right key. There we go. So now we will helps if you actually hit the spacebar. There we go. So now we'll mirror along this point again. And Vectorworks crashed. Welcome to the joy of Vectorworks, ladies and gentlemen. I'm going to reopen that. But yeah, that's pretty standard Vectorworks stuff. I've been using it for about 8 hours today, not a single problem. Doing all sorts of different things, and there you go. As soon as we attempt to mirror an object, that's the defining point. I had also been ignoring the autosave pop-up, which is very funny, so we'll probably be back to square one. Brilliant. Unreal. There you go. First lesson of Vectorworks, always save everything. As much as you can. We'll reopen the document. That is the best thing that's happened all day. Yeah, I know Vectorworks quit unexpectedly. What we'll do is we'll jump into a different drawing, which I was going to take a look at later. We've kind of looked at a lot of basic tools, and we'll keep going with drawing something, and we will go back to that mirror thing. So this is a drawing of a very popular venue in Sydney. It's had some 3D enhancements thanks to Matt Dodo, who's in the chat. And it's a really good drawing to use as an example, and I've certainly done a couple of gigs in here, so it's a cool drawing to look at. So really quickly before we go back to trying to draw something, I'll just show you that this drawing has all the same concepts applied as the template file we were looking at before. Classes for everything. Design layers for everything. This has a couple more classes in it because Matt has gone through and added some for things like seating and roof beams and punter barrier and whatnot. But you can see that this drawing essentially started life as where we were before with just a super basic PDF/DWG, which is just this. So this was essentially how this drawing started life, a rigging points drawing with the venue around it. And Matt has come through and added in a lot of the geometry that makes up this drawing. But this is a very standard rigging plot for a venue. This is actually a really nice one because we get all this information regarding the weights we can apply to points, and all the points are clearly marked. It's super clear information. Some of them it's definitely a bit like guessing game until you send it to the engineer for approval or to the rigging company that is common in the space. So we'll jump back into the full drawing and we'll hide this rigging points PDF thing because it certainly is messy when we're trying to work. We'll jump into a lighting layer and we'll try that mirror tool thing again. So we'll draw a piece of truss in here just like we had in the other drawing. But yeah, first rule, save in Vectorworks because it is absolutely brilliant, the things that will cause it to crash. Great. So let's quickly smash in a piece of truss, set it up as a hanging position, attach a light to it, and go from there. What's Matt said here? Probably should have sent you the finalized one. Probably. I'm sure no one will mind. So we'll insert truss. We'll do the exact same process we were doing before. We'll use a different piece of truss this time. Cosmic and or global and Euro is super common in Australia, so we'll try maybe some 44 box this time. Try 2 meter stick again. We'll merge the truss record again, just like we were looking at before. It's worth mentioning that if you're just tuned in, this will be recorded on Twitch. I think Twitch deletes it after 14 days, so I might try and throw it over to YouTube as well. So we'll draw our truss. For the sake of realism, we'll put our points on. We can use the graying that we looked at before to see where they are without them totally dominating the drawing. And we'll throw everything along, say, these P1 endpoints here. Just going to turn off Matt's awesome 3D for a second so we can see the little dots. Alright, so we'll grab a 2 meter section of truss. Oh, I'll just quickly turn it into distributed insertion. And we'll go along between the points and place. Now, obviously, the only thing about doing it this way is that it's kind of based on the length of the trusses put together rather than the distance that you actually want. So if you wanted to spend more time, you usually work center out. And you can use the mirror tool certainly for working center out like that so that the truss is actually centered between the points. But we're kind of aiming for speed here, especially after that little crash incident. Great, we'll turn our rigging points off now since we have a truss in the drawing. And we'll throw some lights on it. We'll give it a height or a hanging position as well. Yeah, it's definitely disappointing considering the price of a software like Vectorworks that it does crash as often as it does. I first started using this. I know there's a couple of guys in the chat that have been using it much longer than me, but I started using it in 2018. And every service pack and version that comes out every year, everyone says, oh yeah, the performance is way better. And then you use it for 3 days and it still does the exact same things. So it's definitely frustrating, but such is life. It is a really powerful piece of software, and I will say that there's times that I've used it for 5 days with no issues. I think performance of the machine does come into it as well. The laptop that I'm on is not particularly powerful, but I choose to have it on my laptop because it's most it's the best workflow for me, being able to make changes wherever I am. I think though that machine performance definitely does play a part in sometimes whether or not things crash as often as they do. Cool, so we'll use the geometry again. There's our A truss. And we'll give it a height of, say, 7 meters, which is probably already pretty unrealistic in the Horden, but we'll go for that. And we'll throw a light on it. If anyone has any specific questions as well, feel free to throw them in the chat. I think it was maybe Christian was saying the other day that he was looking to color units like you would in WYSIWYG or Capture to make them easy to stand out on final plots. So we might quickly try that in a second. I've always done it a different way, but I tried a new way today and it was kind of cool. So we'll grab a lighting instrument. What this time? I know. Mac 250. Bam. Oh, no items found. Come on. Yeah, here we go. 250 plus. Whew. Unreal. Now let's get an on tour. So we'll select our unit again. Cosmo Pix. Oh, shakes head. Press F to pay respects. So we will put this light on here. And let's try that mirrored thing again. We can see once again we've got a little drop down menu here because it's attached itself to the hanging position, which is actually really cool functionality. Okay, here is one that has bugged me since I've been trying to teach myself, blah, blah, blah. How do I create a top plot view of trusses that are drawn at angles in 3D? A top view of each truss with its instruments in a sheet layer. This was something that I was just discussing with Matt and some other guys. I don't know if Nathan is still in here, Laser Sloth. Matt and Nathan are definitely some of the best entertainment drafts people in Australia, so it's really cool that they're here. So Vectorworks added a new thing called schematic views for doing this, which is really cool. So we'll try this mirrored unit thing really quickly, and then we'll look at that. We'll also try and color the lights, because it is actually something nice, quite nice in Capture and WYSIWYG to have kind of different colored lights in wireframe to make them stand out. It certainly helps when you're staring at a tiny A4 plot in the rain. So we'll find the middle of this truss. Again, I used an odd number of truss. Damn it. And we'll get the mirror tool. So that's now angled at 45 degrees, this unit up here. So we'll find the midpoint here. And mirror. Let's see if it crashes. Wouldn't it? It probably will. No. So my unit has symmetrical angles. So I don't know if that is exactly what the question was, but it appears to have a symmetrical angle around the Z. I'm going to save too. Jesus saves, and so do you. Cool. So we'll really quickly look at coloring the lights, as in coloring the wireframe or hidden line lights, and then we'll look at the schematic views, which is still a feature in its infancy, but I think it's definitely the nicest way to do like complicated rigging lighting layout views, especially if you're doing real gigs, which I don't do, and lights are on pre-rig, because it makes it really like clear when you're building it in the shop what the individual pieces of pre-rig should look like, so you can kind of really easily make diagrams to prep the lights in the shop. So coloring lights, the way that I've always done it, and it's certainly a valid way, is you can jump into the resource manager, go to your open document that you're working on, and find the symbol that you want to color, which is our Mac 250. Wow, what a mess. It's here somewhere. I could search for it, but that would be too skilled. Here we go. Mac 250 on tour. And now, just like we were saying before, when editing kind of a defined object, you can just double click and you'll get some options. Oh, or not, because that will select the instrument tool. So let's right click instead. And you can go edit 2D components and edit 3D components. And what this is going to do is it's going to edit the symbol. I always used to think that it edited the symbol definition globally, so I used to get really freaked out by doing this, but it only edits it in your open document. Certainly, if you want to save the changes globally, you can create user libraries and things, but this, in its most basic form, will only edit this document. So we can go edit 2D components, and it's going to open up this this edit window. Now, if you want to, all you can do is just literally select the light. We'll try not to select the movement ring. There you go, select the light. We'll not select the input too, we'll leave that red. And then you can just go to attributes and just choose your line tool as blue. And then the light's now blue. So that's one way to do it. And then when we hit exit symbol, that'll be applied globally in our drawing. And then you also have to edit the 3D instance. A little bit slow, but it's certainly one way to do it. The second way you can do it is you can apply attributes to class. So if you see, the way one of the ways I lay out my classes for lighting is I have a lighting group, and then there's a whole bunch of automatically generated stuff in here by Vectorworks, so we'll close these. And then what I usually do is I separate by type, and then using layers is how I generally separate by position. So I have like an A truss layer, a B truss layer. So what we can do is we can go to the beam class, and then you can go edit. Oh, not new, crap. We'll actually open up the class manager by double clicking classes up here. That's any of these options in the navigation pane. Over near classes, design, sheet layers, you can double click them to bring up the actual editor. And we can go to, say, our lighting type. Lighting, how does the alphabet work? Lighting. We can go lighting, type, and then say we could assign types to all our lights. So, oh my gosh, do not show this dialog, go away. So we could apply like a spot type, a beam type, a strobe type. And what Vectorworks lets you do is apply attributes to the class globally. So we could say that anything that has a class of beam should have a pen fill of blue, or a pen color of blue and a fill color of white. So you could just really quickly go through and apply classes to all your different unit types: spot, beam, strobe, mulfay, whatever, and then choose the attributes here for the display of them. That's a really good way to do it. But there is a third way, and we'll see how we go with this. Vectorworks has a data visualization feature, which you can apply at like a viewport or a sheet layer level, so that you don't have to have it like everywhere. So then you could still make like wireframe viewports with like black light that don't look stupid, and then you can add colors for your build plans and whatnot. So we can just go to this little red, orange, blue, green thing here, and we'll apply it at the design layer level, but you can apply it at the viewport level. It's actually just in the object info palette for the viewport that you're working on. You go data visualization, you say new data visualization. And so what we can call this is like Mac 250. And then you go display criteria, objects using, is it record or parameter? Yes, you go, objects using light info record, 3D symbol name. No, let me try the instrument type. Oh, sorry, I think it has to be objects using parameter, not objects using record. You can go lighting device. Yeah, here we go. And you can say device type. And then say value. Oh, well, so this is by type, so any moving lights would be this color. We want to go to a further level, which is instrument type. Instrument type, here we go. And now we can say Mountain Mac 250 onto and say that its pen is red. And now hit OK, and let's see if this works. No, it didn't. It might still be hanging on to the style from the previous way that we did this. This was working before. Let's try another viewport. Well, let's just check this. So let's go data visualization, edit data visualizations. Martin Mac 250 on tour. We want to turn this on, apply it, and we want the fill to be solid white and the pen to be solid red with the thickness of whatever. Visualization name 250. Oh, there you go. Okay, I think that I hadn't ticked the apply thing. So let's go over that again now that I've confirmed how to do it. So what you do is you go into this little box up here with these 4 different colored tiles, and you go new data visualization. And so data visualization is acting like rules. If anyone's ever used like spreadsheets with like conditional formatting, it acts a bit like that. So we go new data visualization, or we can go manage to see the ones that we've already created. Here we can see a bunch we've already created. We go new. So we call it, so say like moving light, say like Sharpie, beam, whatever. And we say that our criteria is that any objects that is lighting, or is parameter type, lighting, or instrument, in, why is that not there now? The joys of Vectorworks. Objects using parameter. It was instrument, wasn't it? Wow, that's annoying. Let's have a look again. Edit data visualization. Objects using, lighting device. Damn it, sorry. That was the object. New data visualization. Objects using parameter. Lighting device. Yeah, this is the top layer. Instrument type. And then choose your instrument types. So here we have Martin Mac 250 on tour, but you could just choose any instrument type that's in your drawing. If you just type the first letter, it'll just prompt for the different instrument types. So it is definitely a bit of a long-winded way to do it, but this is how Vectorworks recommend, or at least the tool that Vectorworks imagines you will use for this, because it's temporary. It's only applied at the design layer or viewport level, and you can turn it on and off with just a tick box. So you don't have like the destructive effect of editing a class or editing class attributes. So I mean, if you don't care having colored lights in every viewport, then just edit it with the class attributes or edit the symbol. And the beauty is you can then save those symbols and use them in any drawing, or you can just always apply the same class attributes. Otherwise, do this. I'm sure if you looked more into data visualization, there's a way to transfer these different visualizations between drawings, so that you could always have the same colors applied to the same fixture types. But now we have our 250 ontours in red, based on the data visualization that we applied to the 250 ontour type. Was there another question? Oh yeah, rotating like angled trusses and correct like top plan views. So, and if anyone does have any more questions, feel free to drop them in the chat. We'll probably go for another half hour, which will be finishing at 9 p.m. Sydney time. I'm definitely planning to do more of these, so we can go more step by step through the drawing process, and add in more elements, PA, LED screens, etc. But it is good to kind of knock over some questions and stuff early. I mean, we looked at drawing truss using different symbols and the resource browser, etc. Applying hoists, rigging objects, hanging positions. If you do have any more questions on that stuff, feel free to put them in the chat or shoot me an email. And this was also recorded, so apologies if I was talking a little fast. This is the first one. You definitely can go back through and watch it again to pick up anything you missed. So we will make an angled truss. We'll make it out here in the auditorium, Mardi Gras style. We'll use our insert truss tool to draw some sticks of FD44. Draw them straight, because this isn't really the angle that we care about in this example. We'll throw some lights on it. What's a good light? I don't know. What's a good light, people? Sharpie. Old Faithful. We'll grab a Sharpie. Oh, sorry, I'm breaking my own rule. I need to use the lighting instrument tool, which I think we can double click this actually to automatically select it. Yeah, we can. Sweet. We'll close the resource browser with Control or Command R. And we'll throw a bunch of Sharpies on this truss. So one thing we never looked at before was the other tool in the basic tool set that is really handy for drawing lights on truss. So the mirror tool obviously mirrors along a plane that you define. Another really good one is this tool here. I gotta hide my face. Whoops, I forgot about that. Oh, I broke everything. There we go. So up here in the basic tool set, we had the mirror tool, which is up here, these two little triangles either side of the line. And then we have this move by points tool. So we can grab this. And now one of the modes that this has, often in this contextual menu, we get different modes of tools. So this contextual menu where truss and lighting type and all that was. And one of them is distribute mode. So if we go to distribute mode on this tool, it has really useful to for drawing lights over like a truss. So say you've got 10 lights and you want them over the length of a truss. So we put it in distribute mode, and then we also tick this option next to the modes, which is object retention mode, which keeps the original light. Then let's say we want 10 lights on this truss. So we've already placed one. We'll place a further 9 to get 10. And then all we're going to do is draw a line that starts at this first light and ends at the same point on the truss over this other side. So I won't do it very accurately, but we'll drag and click on the same point on the truss, double click, and just like that we've created 10 equally spaced units over the length of the truss. So we'll grab those lights and we'll rotate them 90 degrees, and then we'll angle this whole piece of truss. we'll just, not Z of 90, whoops. Rotation of 90. Rotate them so they look kind of correct. And I'm just going to quickly create a hanging position from this truss so we can make the rotation process a little easier. Just going to move them over there for now. Grab these sections of truss so we can really quickly rotate them. Spotlight, object conversion, convert to hanging position. All selected objects, exactly the same as we were doing it before. Room truss, use geometry, and now we have a hanging position. I'm just going to do a quick save. We're going to attach these lights to the truss. But just move them back over. And now that will connect them all to the hanging position. So once again, we've got all these drop-down menus. So what we're going to do is we're going to say change trim height of system, and we're going to put it at an absolute value of 5 meters. And we're going to say that we want to change the entire system. We'll quickly look at that function. I am keen to try and answer this question though. So when we select our hanging position, in our contextual menu, we have this button down here that says change trim height of system in the object info palette. And by clicking it, we can change everything that's connected to the rigging system. So all the truss, all the lights, motors, etc. And we have a bunch of different options for how that works. So connected system is everything that is connected with truss connectors. So anything that's, joined onto these trusses via, pins and clips, bolts, whatever, is going to move. Stacked system is everything that is lying on this selected piece of truss. So anything that's connected to it, motors, lights, etc. And entire system is everything full stop that's connected to the truss. We can then move it by to either an absolute value, so we can move it to a value of 5 meters, or move it relative to its current value, so say move it up or down 5 meters, which we just denote by saying 5 meters or negative 5 meters. So we've changed the trim height of this system. Hypothetically, if Vectorworks has worked, everything should have moved to 5 meters, which it has. So we now have a truss in the room at 5 meters with some lights on it. Sweet. So someone was saying to me the other day that one of the really annoying things about using hanging positions is you can't rotate the truss anymore. And I tried it and you couldn't, and I was really confused by it. Stupid problem in Vectorworks that I really hope that they rectify. But I'll show you how to fix it. So we'll grab a front view. A right view. So we're looking at that truss. And we're going to try and rotate it. So we'll go up to our basic tool set and go rotate tool. It hasn't worked, so we'll just choose our view again, right. And we've got our rotate tool, which is a little protractor, and you can see it's actually sitting on the truss because we're in like a right view looking at it from the side, so it's sitting on the face of the truss that we've moused over. We've just got the hanging position selected, none of the lights. Now, if we go to rotate this, it says the dreaded message. Anyone that has worked with these kind of entertainment drawings in Vectorworks knows these messages, that we're not allowed to rotate hybrid objects on certain planes. It is truly the most frustrating message of all time. Now, what this applies to used to happen with lights, it used to happen with a whole ton of entertainment things until Vectorworks finally fixed it because people were like, we need to be able to rotate stuff. It means that the symbol that you have selected, so in this case the truss, has a 2D component and a 3D component. So it can rotate it, if you're looking at it from a top-down view, it can rotate it around that axis because it still looks the same in 2D, it's just pointing a different direction. But if it tries to rotate on the Y-axis or the X-axis, well then it doesn't really... What's being represented in the top-down view isn't going to be correct anymore because it's using like a 2D image, and now you've rolled this truss over. So for instance, with box truss, one chord is going to be pointing straight up, and that's not going to be represented in 2D. So that's why it gives you those error messages. Now, they've fixed it with pretty much every item in Vectorworks now in entertainment, but for some reason it still seems to have this issue when we're working with hanging positions. So the fix is really simple, and I personally like using hanging positions. Some people don't, they just draw a truss and hang lights off it. I like using them because it adds in weights and things. So I'm going to roll with this hanging position, and the fix to be able to rotate it is really simple. You double click the hanging position to be able to edit the geometry. So remember what we were saying before, that when you double click on like a defined item, for instance this hanging position, we're going to edit we're going to drop down a layer and edit the geometry that makes up that hanging position. Same if we double clicked on a symbol, we would edit the geometry that makes up the symbol. And what we're going to do is just in this menu, just tick draw 3D only on the truss. And so now we're only drawing the 3D of the truss, which is perfectly adequate. But now it doesn't have any issues with different planes anymore. So now we can grab this tool, click, no error message anymore. We're going to choose our working plane rotation angle when we use the rotation tool. So the first click says where you want to rotate from. The second click doesn't really matter in this instance. It's saying where the working plane is going to jump to, but we don't really care because we just know where we want to rotate it. So we'll click again, and now we can rotate, and you can see this blue outline moving with the truss to define how we're going to move it. So we can interact with this context menu again by just clicking tab or hitting tab on the keyboard, and now we can type in an angle. So let's say that this truss, we're going to rake it pretty hard so that we kind of see the effects of truss, like angled truss in 2D. So we'll rake it at 45 degrees and hit enter. All our lights move with it because they're all attached to it. Awesome, done. Now if we jump into top plan, you'll see that this truss that was previously the same length as our front truss is now dramatically shorter, which makes sense, right? Because we're looking at it from a top-down view, it's angled, our perception of it is warped. So the question is, how do we actually represent this in 2D so that it makes sense both from a building perspective, a prepping in the warehouse perspective, and so that everything isn't kind of this compressed look because things are angled? So the way that we used to have to do it was basically to create multiple viewports, try and work with different planes. It was really hard. The super cheap way was to duplicate this whole truss, drag it somewhere else, make it flat again, and then use that in a different viewport. But obviously things got real messy quick, and Vectorworks was rendering heaps and heaps and heaps of items that it didn't need to. So rather than trying to do that, there used to be another option that was called like plot map or something, which was useless. The new way to do it is you just click on the truss or any rigging objects, any piece of truss. I'm just going to quickly save again. You just click on any piece of truss and you go Spotlight, Visualization. So Spotlight, contextual menu, Visualization, Create Schematic View. So it says, okay, what layer do you want to put the schematic view on? So we'll say lighting. And what view do you want the schematic to be from? Well, we'll say top because that was the question, and that's where our perception of this particular truss is most distorted. And then we click OK. Now, this is the only thing about this. For some reason, it seems to take a really, really, really long time. So I'm going to use the opportunity to sip on some water. It seems to really only take a long time the first time. After that, things seem to speed up. So I don't know if there's some tool or some process that's starting. Maybe if you have a better computer than me, I'm on quite an old MacBook, this will be heaps quicker. Don't know. There we go. I don't know. Still going. I honestly have no idea why this takes so long. If anyone has a more powerful computer and can tell me whether this takes long for them, I'm really curious, because if it takes long for everyone, I think it's something we should probably tell Vectorworks about. Like, this is getting ridiculous. Maybe Vectorworks is frozen. It's always a possibility. Don't use a piece of poo. Okay. Lasersloth is the kind of guy that has some mad rig. So now it's thrown it over at the drawing origin, but we've now created a schematic view. It tends to put them at the drawing origin. There's probably a way to not do that. So I'm going to drag this hanging position over here, which is where we could put it in, say, a viewport. And now we have this truss represented in 2D as a schematic view, and therefore it's not distorted. So just like that, we've created this schematic view item And the really cool thing about it is that they're linked. Yeah, see, anytime I seem to interact with a schematic view item, my computer seems to catch fire. So yeah, anyone with better hardware, tell me what's going on with that. So the best thing about this is that they're linked. So any time we interact with a unit on the schematic view or on the original 3D geometry, they'll move to match each other. So that's great because it preserves our original geometry. So whereas we had to originally either change our geometry by making the truss flat again or mess around with heaps of different viewports, we've preserved the geometry and it's the same. So when we click the item, we see that we have hanging position in schematic view. It says in the object info palette. So it knows that this is a schematic view. It's also colored blue just because that's what my attributes were set to in that class. But if I were to grab this unit now and drag it right up next to this one and place it, question from Laser Sloth. Is there a reason why you're drawing 90 degrees rotated? I've always found drawing facing from the stage at least makes the most sense, especially when you're working off X and Y and a datum. No, there's no particular reason. It's just how the drawing that I'm in is working at the moment. I could use that custom plan rotation to rotate the drawing, which is annoying because our X and Y values flip. So I go -90 to face or look away from the stage or vice versa. Which is a bit annoying because our X and Y values flip. We go from normal X and Y to screen X and Y, or I could just rotate the drawing, but it's just how the particular drawing that I'm in is drawn. The reason for that being that there's some text off to the side here that's in landscape, as it was originally a landscape PDF. So there's just this text here, and that's the only reason this drawing is this way. But yeah, I do agree that drawing from the front is a lot easier. Anyway, you can see that the light that we moved on the schematic view has replicated itself on the actual drawing, but all the geometry is preserved. So, yeah, schematic views. I don't know if that answers the original question. The question was, here is one that has bugged me since I've been trying to teach myself VWX. How do I create a top plot view of trusses that are drawn at angles in 3D, i.e. I want a top view of each truss with its instruments in a sheet layer? Well, we have the top view done. It's not distorted. So I suppose that's the first part of the question done. And the examples that Vectorworks give when doing these schematic views are actually a lot more complicated geometry. They're like arches and things, and they display each part of the arch as a separate straight truss, which we could do by just selecting one piece of truss. But we selected the whole hanging position, all of the pieces of truss, so we created a schematic view for that whole hanging position. So yeah, now we could go view, create viewport, and we'd have both the original geometry and the schematic view geometry, and we could present that nicely on a sheet layer. So sweet. Any other questions? So we kind of did like basic drawing setup, hoists, truss, lights. We might look at some other different elements. Next time we do this, I've been playing a lot with the speaker array tool because I made some changes to it in the latest version. I've also been trying some different things with blended projection screens and things, so we could definitely look at some other elements next time, but just about been going for 2 hours here, so I might wrap this up in a sec in case anyone else has any questions. Custom plan rotation is ace when you don't have time. Yeah, it is very handy. Especially even working on like angled elements, being able to go at 45 degrees and see things in straight lines is really handy. "16 people watching. Sick." When I duplicate items, is there a way for them to retain the hanging position assigned to the original instruments? If I'd say the reason that that's not... I'm just trying to read that. I'd say that the items not retaining the hanging position is probably because by default, Vectorworks does offset duplications. So when you Command D or Control D to duplicate something, it spits it out offset to the original item, and probably because that item is landing in dead space over here, it's probably not taking on the hanging position characteristics. So I hate that. Only half of the time it seems to retain the hanging position assignment. All right, let's try it. So this item is definitely on the hanging position. You can see that in this position field, A truss, which is populated. So I think maybe the reason it's not retaining it is because of offset duplications. If I duplicate array of fixture, okay, let's try a duplicate array. So here's a handy tool that we haven't looked at. We looked at the move by points tool here, which kind of distributes along a line that we draw, but we haven't tried duplicate array. So duplicate array is in edit, duplicate array, and what it does is it duplicates an item a certain number of times, offset by a certain X, Y, Z value, and you can get really complicated and do like rectangle grids and circles and things. Yeah, that's very true. Figuring out VWX is 100% working out when it was meant to do something and when it wasn't. Yep. Couldn't agree more. So we'll do a linear array with 7 duplicates, and we'll move it down, each one down the y-axis by negative 80 centimeters. Let's try that. So we've duplicated, we've made a bunch of things 80 centimeters apart, 7 of them. If I click these, this one has retained the position. It seems that they have that time, but yeah, maybe you're right. Haha, sloth. Yep. Vectorworks will crash if you face the moon from the northwest and had a pina colada. When you say half aren't retaining, do you mean half in the duplication or half of every duplication that you do? That doesn't make any sense. Do you mean like half of these ones that we did in one single duplication didn't retain it, or every time you do a duplication, sometimes it does work, sometimes it doesn't? There is a tool. Great question, Stevie. Someone who's more of an expert with capture might be able to help me. The standard moving forwards for going into visualizers with Vectorworks drawings is, along with the new GDTF fixture type, is this MVR My Virtual Rig format. So it seems like, I think I was watching Alex's stream the other night, L8 has just started supporting MVR. Vectorworks Vision has supported MVR for quite a while now, but I don't think Capture does. Yeah, Depence definitely does. Depence 2 I have been playing with in this coronavirus period, and yeah, Depence 2 is very impressive. I don't think it's as complete as something like L8 or Capture yet, but it's pretty incredible. The rendering engine and efficiency is nuts. I have 2 segments of GT. Oh, cool. Sloth has just come through too with some good information for capture users. That's the way that it tends to go with a couple of other visualizers as well, MA3D, and in my experience, you need to export a 3ds and then bring the units in separately, which Vectorworks does via a plugin to MA at least. Okay, let's try that. Yeah, it sounds like what you're definitely experiencing is a glitch or a bug. Let's see if we can recreate it. GT, Tyler, GT. I don't even know where that is because no one in Australia has real trust. Let's do it this way. Objects, entertainment, trust, Tyler. Why am I not seeing Tyler? What am I doing wrong here? GT. Here we go. Straight Tyler Trust GT 10 foot. Q. So we'll insert a truss. Oh, I lost that again. Oh, just gotta scroll up. Truss straight 10 foot. Okay. Merge the format. Merge the format. Okay, so draw a couple of segments of GT. Lighting instrument tool. Sharpie. Hang the light on the center. I should mention this 00 that's appearing is just due to my label legend that's my default in this template file being selected. We might look at like custom label legends and whatnot in the next stream. Probably try this and then we might wrap this up. If anyone has questions and or ideas for future streams, definitely feel free to email them, send them in the chat, shoot them to me on Facebook if we're friends, and I'll try and solve some more Vectorworks problems. Okay, so we have 2 Sharpies there. If we go edit, oh, we didn't make this a hanging position, did we? Whoops. Is your section of GT one big hanging position, Christian, or multiple separate ones? So we can see that this that's so weird. You mirrored the first Sharpie and then none of the duplicates have it. Yeah, the hanging, like the attaching to lights at least to rigging objects does seem occasionally to bug out. I found pretty much everything else, hoists, truss connections, and truss drops, bridles, audio, like all that stuff seems to attach fine. It only ever seems to be lights that has issues. So these 2 that I've created definitely have... Oh, well, there you go. This unit that I've created here already doesn't have a hanging position. There we go. So I'll drag it on. I've got my little red line. I'm not sure how Vectorworks is planning on hanging lights on truss or Tyler like that, but that's okay. Move it over. So that now has GT. That now has no position. Sick. There we go, GT. So we got 2 lights, both with the GT position. And we'll go edit, duplicate array. I don't know, what's my duplicate gonna, what's my offset here gonna be? Like a foot? I don't even know. If I'm in metric, can I say 1 foot? Minus 1 foot. No, it doesn't like that. Let's say like 0.3 meters. Oh, sorry. What am I talking about? Let's go like... So the units I duplicated at least seem to retain the position. It's probably just a bug. Yeah, I'll look at the photo you sent. I will say that I have experienced a lot of weird stuff. The way to fix it seems to be dragging away. I know it's a pain, or dragging it and dragging it back. There is a command too in Spotlight that, I mean, maybe if it's only an occasional problem. In Spotlight, you can go Spotlight. It's in here. I think it's in rigging. It's the command called attach loads. Might be in the rigging tools actually. Not insert load. That's for inserting a hypothetical point load. It must be in hanging position. Oh, I know what you do. You go to the hanging position, you right click, and then you go manage loads, I think. Yeah. So I believe when you're in this menu, you can attach loads to the truss. It doesn't seem right though. That's one to Google. Attach loads with hanging positions. There is a command somewhere that you just select all your objects and then just click the hanging position, and it'll jump on if it's not already there. It doesn't move, it just becomes associated. Oh, here we go, attach to rigging object. So you can just select all your lights and say attach to rigging object, and then just choose the piece of truss, or the hanging position, sorry, and now they'll all attach to that position. I've been pretty good recently. I haven't had a heap of issues with lights not attaching, but yeah, it definitely has been buggy before. It might be one to just keep playing with. Yeah, attach loads. I have used that in the past because otherwise you're trying to grab lights, drag them away, and drag them back on. And then you get it a bit wrong, or it lags out because it's trying to move everything. So you can, yeah, right click on your lights or any hangable object according to the Braceworks functionality in Vectorworks, and anything that can be hung will respond to that attach to rigging object command. Yeah, I say Braceworks in quotations because it's very powerful, but it's very expensive, and no one uses it for that reason. Except Europeans, because they're cool. Sweet. Well, to the 15 of you still watching, thanks so much. I might wrap this up now, just because we've been going for quite a while, 2 hours or so now. But yeah, I definitely plan to do some more of these. So if this was something you enjoyed, I'm going to leave the stream setup all set up. If you have any feedback about the stream content or the setup, I hope the audio is okay. I'm kind of monitoring via my interface, so it's a bit hard to hear what the stream actually sounds like. But yeah, feel free to plop some ideas or any problems you're having, and we'll try and do some more streams and sort it out. So yeah, cheers for watching, guys.